It's such a pleasure to welcome you all here, and this is a wonderful moment. Um, it was great to see that the Moore Foundation and NSF are supporting this event. I'd like to just give some thoughts myself about why I think it's a very important one. So we've been through now here at Berkeley, starting actually around the period of 2013, a lot of organizational change when Moore and Sloan Foundation supported the creation of this interdisciplinary space. It's in the central library, and that's because it was already very clear at that time that the tools of data science, machine learning, and so on were going to have enormous methodological impact across many, many, many disciplines in the entire university. And that has been shown over and over again in the years since to be true. Just last weekend, we were at, the Chancellor and I were at the first graduation of undergraduates who are majoring in data science, in letters and science here at the Berkeley campus. Some of those students were actually getting a 2018 degree, but they held off until 2019 because the degree hadn't yet been approved, but they wanted that degree so badly that they waited. And the level of energy and excitement around this was palpable. These were students who came from backgrounds in sociology, psychology, physics, electrical engineering, and computer science. Essentially every part, public health, every part of this university was participating in it. And in most cases, the energy and excitement around it is because it has practical implications. People can produce information that is somehow, let's say, vetted in a statistically important way, in a significant way, that helps them correlate phenomena and therefore reach practical conclusions that would help them with regards to areas as diverse as you know in the commercial marketplaces as social media and advertising, but all the way to many other phenomena that have practical applications today in society. But you will be, I think, at the forefront of the next 10 years at the core of what a part of data science will be all about in this topic of machine learning and physics. The topic that underlies it is really whether these advent of massive data sets, the ability to mash them together in significant ways and so on, will that really also lead to the ability to have true physical understanding emerge from those things, not just to be correlative, but actually causative in the understanding of what comes out. And I think physics really is at the core of being able to do that. I am experiencing this myself personally in my research group. We're studying nanocrystals. We grow tiny crystals. We study their physical and chemical behavior. They're quite complex systems. And for about 3 years now, we've been running projects mainly because my students and coworkers could come and get educated here and in some of the other data science activities around the campus. And we've been tooling up ourselves. So as an example, we can try very hard to be predictive in knowing what it is that will happen when we try to grow our tiny crystals. And so we have a system now in which we've got the ability of crystals to form either in two different phases, depending on the precise conditions. They'll have a different chemical composition, but they also can form cubes and plates and wires, and they can have different sizes. All of these things can go on at once in one system. And so we have a robotic system that is now able to collect data across an enormous parameter space and observe those. And what we would really like to know is, can we use what we understand the combinations of kinetics and thermodynamics that would relate these different phases to each other, and what we know about how materials transform from one structure to another. We know lots of things about that. Can we take one of these data sets and actually get information about the underlying physics that governs which one of these combinations we get? And it's a fascinating question, and so far, it's really hard. And so we're on the sidelines here rooting for you to make some breakthroughs, because all of our lessons teach us that if this group is able to apply some of the tools to uncovering similar phenomena, whether it be in cosmology or condensed matter physics, we know for sure that in materials chemistry, those tools will be very important for us, and we will use them very rapidly. So I'm rooting for you, and I also think at some level, coming back to the methodological issues, data science is going to be used extensively. We don't create an undergraduate degree lightly. We know that that's going to be used by students for their whole career, for their whole life, and that there will be students using it for many, many decades to come. So we already know that to be true. But ultimately, methodologically, whether this turns out to be a community which in the next decade can find causative phenomena using machine learning will, in my opinion, be a real turning point for data science in the university. Will it simply be a practical tool that kind of works, or will it actually be foundational in terms of how we make discovery and in teaching us about what leads to the origins of phenomena? And that's really where you're at. So I think it's exciting, and I'm looking forward to hearing. I hope I can drop by later this evening and just chat with some of you to hear how the day went. So good luck, and I wish you the best.
Okay, so we're going to kick off with the first session.